This meeting is being recorded.
In the next section of chapter 12, we're going to take a look at diols or alcohols that are formed with more than one hydroxyl functional group. Oh, sorry. So I started on the wrong slide here. So we're going to look at diols here, and we're going to start with how they're named. So they're named the same through the same method as alcohols, except the E is not going to be dropped now from our parent alkene. Instead, we're going to keep the E, and then after that, put diol. So we have two, so the prefix di in the all ending that we've seen with other alcohols. So in this specific compound here, this is named as propane diol, and we see that we have 1, 2, 3 carbons, and then on carbon 1, we have a hydroxyl group, and then on carbon 3, we have a hydroxyl group. In this case over here, we have 1, 2, 3, 4, 5, 6 carbons, and on carbon 1, so I named this backwards, didn't I? So we would start here at carbon 1. That's why it didn't make sense. 2, 3, 4, 5, 6. So we have our hexane, 6-carbon chain. We keep that. And then there's 2 hydroxyl functional groups, one at carbon 1, the other at carbon 5. There are some common nomenclatures that can be used specifically with ethylene glycol, which is a 2-carbon diol, and then a propylene glycol as well. So these are accepted by IUPAC, and you might see these used interchangeably. They're common names rather with other IUPAC glycol or alcohol diols rather. So glycol means 2 hydroxyl functional groups. This next slide, we can see the preparation of diols in various ways. So we can reduce ketones or diketones specifically. So both ketone functional group sites can be reduced. We have our least selected method here that would reduce all pi bonds as well, all alkenes. But in this case, we would produce the same product, the same diol, no matter which of these 3 methods we use. We could use the metal catalyzed hydrogenation to reduce. We could use our reducing agent, lithium aluminum hydride, or this other reducing agent, sodium borohydride in methanol solvent. And either of these 3 pathways we will generate our same diol product here. So on this last slide from this chapter, we see that we can also perform an addition reaction to our alkene. So we can add across that pi bond. We see the reagents, the peroxy acids up top here, and then our workup step, we have our acid in step 2. Then we have catalytic osmium tetroxide and NMO shown down here. And depending on whether or not we want to produce an dihydroxylation, an anti-diol, we could use the peroxy acid pathway, or if we wanted to end up with a syn dihydroxylation, syn product for our diol, we could use this catalytic osmium tetroxide and NMO path instead. So we will continue with the next section in our next video.